What's up guys, Nexi here. 2 months ago I made a review of Anycubic Chiron 3D printer, which Anycubic sent me to test and to make unbiased review, which I did. During my testing I found a lot of quality control related issues and other production mistakes. After that I upload my video review, which you can find in the video description. Anycubic leave a comment and state that they will handle all the issues that I found during my testing. Today, after more than 2 months since I made my first video review, I received a new Chiron. Here is the box. Let's open up and check it out. Now, before you order this 3D printer, make sure that you have enough space for it, as it barely fit on my bench. With a weight of 17 kilos and size of 650 by 800 by 640 millimeters, Anycubic Chiron is one of the largest desktop 3D printer on the market. At first, when you open the package, you also get the detailed instruction manual with the upgraded level manual in the paper form and on the SD card. The package is divided into the 3 sections: the upper part of the frame, bottom part of the frame, and the bag, in which you have the frame parts, screws, tools, this sharp print removable tool, SD card with a USB reader, complete spare hot end with a Teflon tube, auto level probe, USB cable, AC cable, and you also get 1 kilogram of the filament. Assembling of the Chiron is very simple and straightforward. First I free the heated bed from the plastic foil, and then I cut the cable ties. Then I take off this paper cover to make sure that the heat bed glass is not damaged in shipping. And on this heated bed you have this protective paper which has some warnings and recommended heat bed temperatures. Then I place upper part of the frame in the place and I screw down 1 frame screw with a hand just to hold upper frame from sliding down. Then I lift the printer on the side and screw down the 2 frame screws with the washers, but not too hard, just barely. Then I lift the other side of the printer and I install the 2 left frame screws, but this time I screw them hard all the way in. Then I lift the right side of the printer again and I tie down the screws all the way in. Next, on the bottom frame side, where upper frame meets the bottom frame, I install the frame brackets. The speed is crucial here if you want all T-nuts to open and lock inside these extrusions. Test 1 by 1 screw and recheck them, are they actually open inside. Here is how they should look when they're installed correctly. Next I install the spool holder and LCD. Then I plug each cable in a corresponding socket. Finally I recheck the belts on X carriage and on the heated bed, and I recheck and readjust the bearing wheels on X carriage, heat bed and a Z carriage. Assembling is complete and it took me around 20 minutes. And I did not notice any QC related issues in the term of the hardware on my new Chiron. So far, so good. And here's the Anycubic Chiron fully assembled. And now let's do the overview and run some specs and features of this machine. Chiron frame is made of metal aluminum extrusions. Very simple and a strong frame design, similar to the CR10 S4, but with some few changes and improvements. For example, there is no extender control box and everything is attached to the frame underneath the printer, and that's why the Chiron has these extended legs on the corners. Filament spool holder is also attached to the frame and it's easy accessible, so you can change the filament pretty quickly. And there is a filament runout switch, which will pause the printing when you run out the filament. This feature is very useful if you print some huge objects. On the heated bed stepper motor, there is a stepper damper, which lowers the heat bed vibration, which is nice. On the right side, there is a color touch screen for navigation through the software. Screen has a good viewing angle and it's a quick and responsive. Chiron software is a simple, very easy to use and very similar to the i3 Mega. My version of the software is 1.2.8 compared to the previous 1.2.4 version, who had some bugs and the extruder steps was not well calibrated. I reported that to the Anycubic when I was testing the Chiron prototype around 3 months ago, and Anycubic team fixed it in this new version, which is great. Anycubic Chiron has a huge build volume of 400 by 400 mm on the X and Y axis and 450 mm on the Z axis, so it's a pretty large 3D printer and you can print some huge objects. To make print sticks on the heated bed, Anycubic used this Ultra Base Pro glass surface, which works great, and when it's heated up the filament sticks very good to it, and when the surface cools down it shrinks on a micro level and it's kind of pushy model from the glass, so you don't need to use almost any kind of adhesive or force when you remove your prints from the glass plate, which is great. Chiron has auto level feature as well. It uses this micro switch as a probe. You simply attach it to the X carriage, and when you click on auto level, the printer who is using this probe take measurements on the 25 places over an entire glass surface and store them in a memory, which then you can fine tune in a real time, each on the specific point or instead all at once to get that perfect first layer. This auto level actually works great, and after when I did it once, I print this heat bed level test, which G-code was on a micro SD card, and I got perfect results from the first try, which is really impressive considering the size of the heated bed. Instead of the standard Z-stop micro switch, there is a sensor type switch on the both sides of the Z-axis, which is very good, as when you home the printer both sides of the Z lead screws get level on the both sides every time. Hot end is 24 volt type E3D V5 clone, and it's all metal hot end, and it can warm up to 260 degrees Celsius. Combined with a Titan clone extruder, you can print all kinds of filaments such as PLA, PETG, TPU, ABS or nylon on this machine without any mods, and since it uses E3D nozzle type, you can change it to all kinds of the nozzle size pretty cheaply. On the side of the X carriage there is a separate fan for cooling the filament. It has the 3D printed duct nozzle, angle is good and it blows air where it should. This duct nozzle seems to be upgraded compared to my first prototype version from 3 months ago. For powering the heated bed, there is a huge 1000 watt 24 volt 42 amp power supply with a 2 external MOSFET, and it can warm up the heated bed to 115 degrees pretty fast, which is awesome considering the massive size of the heated bed and no insulation material underneath. My guess is that with the insulation under the heated bed, the temperature can be even higher and warming up time could be even faster. So I highly recommend installing some heatbed insulation, as this mod can save electricity bill as well. For powering the motherboard and other components, there is a second 24 volt power supply in the control box. Motherboard is 3 Gorilla and it has replaceable stepper drivers, which is nice, as you can upgrade this printer in the future with some silent stepper drivers like TMC 2100 or 2130 for example. On this final version, there is a fan directional case, which makes sure that the fan is blowing air exactly on the stepper drivers, which my prototype version did not have. On my previous test Chiron, I had a problem with a terrible fan noise that was coming from the control box and the power supply. This new Chiron is a much better. Fan noise peaks around 58 dB, which is a bit loud for some people, but is not terrible like before. I could make this printer much quieter with a few mods, and let me know in the comments if you're interested in that kind of video. To lower vibration that comes from the printer, I'm using these Ender 3 damper legs that are remixed from the Thingiverse, and now they are able to hold the Chiron weight and they are working very well. I also installed the stepper damper on the X-axis as well, and now it's much better. Next, for the offline printing, there is a supply microSD card with adapter, or you can connect the printer to the PC and print from the computer directly. For slicing software, printer can use Cura, Simplify 3D or any other type of slicers. In the latest version of the Simplify 3D, there is an already printing profile for Anycubic Chiron, and if you use a Cura, you can use CR10S4 printing profile with a few adjustments. I will leave my Tune Simplify 3D and the Cura profile in a video description that you can use with your Chiron. And now, let's talk about the print quality. My first test print was the few bridging and the few retraction test, just to test the new duct nozzle and to retest few different retraction settings. When I got my best results, I sliced my first 3D Benji using the Simplify 3D. Speed that I used here was the standard 40 mm a second, and the layer height was 0.2 mm. Print results was very good, almost perfect, and it's like night and day comparing to my first Chiron that I got 3 months ago. Then I test the 3D Benji again, but this time I lowered the layer height to 0.1 mm. Speed and temperature was not changed. Again, result was great. Very nice print quality in 0.1 mm layer height. No complaints here. Next I print 3D Benji again in 0.2 mm layer height, but this time I scaled the model to 200% scale and I increased the speed to 60 mm a second. After a few hours, printing was finished, and again, result was very good. Nice. For my next print, I found this Halloween model with the 3 skulls. It has a pretty nice detail on it. I used the gray PLA from the Printer Pro, and this model printed very nice without any supports in 100% scale. Print surface looks great, a lot of details, and I like the color too. Very nice results. Now, since this model was printed just fine in 100% scale, I wanted to print it again, but this time bigger. I scale up to 200% and I use the silver PLA. Again, I didn't use any supports, only in the bottom, but that was a mistake. And on the places where support should be, the print quality was very poor. So if you want to print this model in a larger scale, make sure that you use supports. Overall, on the front side and on the areas where support was not needed, print looks very good. And since that was my mistake, I call this print successful. Overall, pretty good results. Okay, so far, so good. It seems that the Chiron can handle the long prints without a problem, but now it's time to print something large to test the full scale of this printer and as well to see how this printer will handle at least 50 hours long printing time. I found this whole statue and I scale up to the maximum Z height, which was 450 mm. This time I use supports. I set 3 parameters on the wall and no infill to save some filament and print time. I load some green PLA and I start to print. Printing took over 70 hours to finish with a stock 0.4 mm nozzle and with 0.25 mm layer height. Chiron passed this long printing test without a problem, and the result was fantastic. Look at the details and the size of this Hulk. Nice smooth surface and nice details. Very nice indeed. Here is the comparison between the Hulk that I printed with the TiVo Flash, which has the standard print volume, and the Anycubic Chiron. Look at the difference in the size. Crazy. Alright, that was the test prints with the stock nozzle, which is 0.4 mm. But what about the bigger nozzle? Chiron is almost twice the size of the regular 3D printer, and what if we use the twice of the size of the standard nozzle as well, like 0.8 mm for example, or even bigger? Well, with 0.8 mm nozzle size, you can go with a twice the layer height and only 1 parameter on the wall instead of 2. What does that mean? That means much faster printing time. For example, I print this vase in a spiral mode with 0.6 mm layer height in just 7 hours instead of 14. Not only that this vase is looking very good in such a huge layer height, but is much more stronger and more useful than if this vase was printed with a standard 0.4 mm nozzle. Walls on that vase will be very thin and fragile. On other hand, the layers with the 0.8 mm nozzle are much more visible, but it's not too bad, and in fact, in my opinion, this vase looks great in 0.6 mm layer height. Alright, 0.8 mm nozzle can be very useful for printing some vases with not so many details on it. But what about if we want to print 3D Benji, for example? Is it possible? Yes, it is, but you need to scale up the model if you want to keep some decent details. For example, I print this 3D Benji in 200% scale, 0.5 mm layer height, and only 1 parameter on the wall, in just 1 hour and 40 minutes. How does it look? Well, I will say that this 3D Benji looks very interesting, and it's as solid as rock. Just one tip if you want to print with a larger nozzle: in the Simplify 3D, you can change position of the start layer. I choose mine to start in the corner of the boat, and by doing that, start layers are less visible instead that I leave them on the random like here. So you might want to play with these settings and with this one here as well, as they can help you to get better surface of your model. Okay, my next print that I printed with 0.8 mm nozzle in the full size is this grot model, which I want to print it with my last spool of white PLA. But I made mistake, and I select wrong model on the SD card, which was sliced just for a test without any support when I was comparing print time with the different settings, and my print was doomed. Look at my grot now. From the back he looks pretty good, even if he's printed with only one parameter on the wall and no infill, but from the front he looks like he got additional mouth, or even worse, like somebody has cut his throat. 15 hours and one spool of filament was wasted just because I select the wrong file. Well, here we go again. This time I select right file and I use black PLA that I got with the printer. Only one tip, you might want to use the brim option next time when you're printing something this large. Brim can help you keeping the support in the place, and the retraction vertical lift can also prevent nozzle not to hit and knock off the support like mine did. To fix this without cancelling the whole print, I used the tape to keep support in place, and it worked. 14 hours later the printer was finished and the results was pretty good overall, with a lot of details, and only place that was not printed well was the chin, where I add only one large support and that was clearly not enough. I should use here a few smaller supports instead of only one large, and I should make them more dense. Also, I want to say that support printing with 0.8mm nozzle is very strong and they are hard to remove, so you need to be careful if you remove it from your print. You might damage it. Overall, this is not too bad. Consider that this is printed only with one parameter and the model feels pretty solid even if he is completely hollow. I would say this was a successful print. Pretty good results. Next that I want to print with a 0.8mm nozzle is this cool looking foldable Robot R that I purchased from the Lab 365. Since Chiron has such a huge 4mm heated bed, I scale up the model to 250% and I use the red PLA. Again, only one parameter on the wall. We will see what results we're gonna get. I leave the printer working undernight, and in the morning print was finished. Well, I'm impressed, all details came up pretty good. Thanks to ultra base glass surface, I basically just pick up the print from the heated bed without effort. Now to fold this robot in one piece without cracks, since it's much bigger than it was originally designed, I use this small torch and I heat up the folding size, and slowly I fold down the robot in one piece. Here is our robot, successfully printed the 0.8mm nozzle. Very nice design, all the details came out great, and the print results overall. But something is missing. I know what, he is missing antenna, his jetpack, and the gun. Done. Now he's complete, and now he is looking much better. Very nice model and very nice results. By the way, if you notice this line on the back of the robot head and on the jetpack, this is the starting point of each layer like I mentioned before. Since this is printed with a large nozzle, it's much more visible than with the stock one. I print jetpack one more time, but this time with a random starting layer point, so you guys can see the difference and choose which one you prefer more. So playing with the settings is definitely way to go if you're printing with a large nozzle. To summarize, printing with a 0.8mm nozzle gets you much faster print time, very strong parts, and very low risk of nozzle clogs. Disadvantages are, the small parts will lack details, layers will be more visible so you might don't like the look, and you will use much more filament than before. Now back to standard nozzle. Since the heated bed on the Chiron can reach over 100 degrees, it can handle ABS just like any other open frame 3D printer. I print this octopus in 200% scale in a blue ABS, and I got pretty good results. I used brim to prevent ABS from warping and it did the job. No complaints here. Pretty nice results. Next I test TPU or flex filament, and at first I tried to print the same octopus again, but I did not hit the right settings right away, so I got some under extrusion and some holes in my model. Later on I started tuning the settings and I print this quadcopter arm few times, before I got the results that I wanted. Then I print these spiral ways and I got great results. Very nice. Thanks to the Titan extruder and with the right settings, Chiron can handle flexible filament just fine. And for my final print, I print the same octopus again, but this time I print the smoother version that I remix and I use a Printer Pro Silver PETG. I got very nice results with this PETG and I have no complaints. Nice smooth surface and nice details. Very nice indeed. Well guys, I got to say that this final version of Anycubic Chiron is awesome. I had no issues with this printer in over 170 hours of printing. Design, specs and the build quality of this printer are great. Print quality is very good and Anycubic did really good job fixing all the issues as they promise. I have no complaint on my Chiron now, buyers' feedbacks rate are high as well and the price is decent. Community behind this printer are growing as well. Right now there is a 2 Chiron Facebook group with almost 600 members each, where you can get any help that you might need, or you can just share your thoughts, mods and the print results. On my opinion, Anycubic Chiron is a very good choice and I can definitely recommend it. Alright guys, that was my final review of Anycubic Chiron. All the links you can find in the video description. Don't forget to like this video. Thanks for watching and I see you next time. Bye bye.